So we're going to do the same thing as yesterday. The only difference is that now they give us the end result. So we're basically proving that one side of the equation is equal to the other side. Okay? So yesterday you just had to simplify as much as possible. Here they're going to actually give you somewhere that you want to get to, and you have to simplify the other side to get to the other side. Yeah. Okay? And you always want to start with the complicated side. All right, so let's look at number 1. So number 1 is cosecant theta times cosine squared theta plus sine theta is equal to cosecant theta. All right, so look at your reference sheet. What can we change about that left side? Because we want to simplify that left side. So cosecant is 1 over sine theta times cosine squared theta plus sine theta. All right, and now basically 1 over sine theta times cosine squared theta is cosine squared theta over sine theta, and I want to add sine theta to that. But in order to add fractions, what do we have to find? What is that called? A common denominator, right? And so the common denominator is going to be sine, so I have to multiply this side by sine theta over sine theta. And so once I do all of that, it'll be cosine squared theta over sine theta. And then sine theta times sine theta is going to be sine squared theta over sine theta. And so we have a common denominator, right? So we can combine our numerators. What's cosine squared plus sine squared? So it's going to be 1 over sine theta. And 1 over sine theta is equal to what? Cosecant theta. And so we just proved that that left side is equal to that right side. Make sense?
Is there going to be some that are wrong?
No, it's always the right answer. We have to prove it. All right, let's look at number 4. So number 4, I have tangent x times secant over tangent minus tangent over secant, all in one quantity. And we have to set that equal to cosine, so we have to figure out how that equals cosine. Okay, whenever we're adding fractions, what are we supposed to find? Common denominator, right? What is the common denominator between tangent and secant? All right, let's think about this. 1 over 3 plus 2 over 5. How do I add these together? What is the common denominator? 15. How'd you get 15? Okay, what is my numerator for 15? For this left side. This one is 5. And this one? 6. How'd you get those numbers? So 15 divided by 3, which is 5, and then so you multiply 5 times the numerator. So basically what we did on this side was multiply by 5 over 5. And then on this side we did 15 divided by 5, which is 3, and then 3 times 2 is 6. So basically over here we multiplied by 3 over 3, right? Same thing over here. We're going to multiply my first fraction, which is secant x over tangent x, by the opposite denominator. So over here, you multiply by the opposite denominator over itself. So I'm going to multiply by the opposite denominator, which is secant x, over itself, which is secant x. And then we subtract the other fraction, which is tangent x over secant x. What am I going to multiply this by? Tangent x over tangent x. All right, so it's the opposite denominator over itself. Okay. So then tangent x. So here secant times secant would be secant squared x over tangent secant minus tangent times tangent would be tangent squared x over tangent secant. And so now we have a common denominator, so we can combine our numerators. So what would secant squared x minus tangent squared x be equal to? 1, right? So if you look at your Pythagorean identities, it's tangent squared x plus 1 is equal to secant squared x, right? But if I subtract tangent squared from both sides, this will cancel out, so I'm going to be left with 1 equals secant squared x minus tangent squared x. So this numerator is now going to be equal to 1. Now what can I do? What about them? There's something better I can do. Right, so this is on the numerator, right? This is over 1. This is in the denominator, so tangent divided by tangent is just 1. So I'll be left with 1 over secant x. And what is 1 over secant x equal to? Cosine x. Okay? Make sense? Okay, try number 5. Try number 5 out. Okay, let's look at number 5. So if you notice, they both have cosecant in common, right? Cosecant squared. So I'm going to factor out a cosecant from both of them. So cosecant squared theta and cosecant squared theta. Right, so that's going to be on the outside. Now, what's cosecant squared over cosecant squared? What does that equal? 1. Minus, now here cosecant over cosecant divides out, and what's left?
Sine squared.
So it's going to be 1 minus sine squared theta. Okay. Now, what is 1 minus sine squared theta equal to?
Cosine squared.
So cosecant squared, or let's change the cosecant squared as well. What is cosecant squared equal to?
Sine.
1 over sine squared. And this is equal to cosine squared. Right? What is cosine squared theta over sine squared theta equal to? Cotangent squared theta.
Why'd you put it under? Oh, because you multiply.
Because I multiplied the two fractions. You have to remember that's over 1. So it is correct. It does equal cotangent squared theta. There's actually an easier way. Okay, so cosecant squared theta minus cosecant squared theta sine squared theta. Cosecant and sine are reciprocals of each other, right? Sine is a reciprocal of cosecant, cosecant is a reciprocal of sine, right? Whenever two reciprocals are multiplying each other, what does that equal? 1, right? So this just equals 1. So cosecant squared theta minus 1. What does that equal? Because of the Pythagorean identities, if you subtract 1 from the equation tangent squared x plus 1 equals cosecant squared theta, right? If I subtract 1 from both sides, I'm going to get cosecant squared minus 1 is equal to cotangent squared. Make sense? So there's 2 ways you could have done that one. Oh, my bad. That's cotangent. Okay. Now let's look at number 6. So number 6, we're going to deal with the even and odd identities. So here, tangent of negative u, what is that equal to? Negative tangent u. And then sine of negative u, what is that equal to? Times negative sine of positive u. And then cosine of negative u, what is that?
Positive cosine.
So cosine is an even function, so it doesn't matter what, if the u is negative or positive, it's still going to end up being positive. Okay, now here I have a negative times a negative, so that's just going to be positive, right? And here I have sine over cosine times sine plus cosine u. So I have fractions, right? So I have to multiply this cosine u by what? No, I want a common denominator. Cosine u over cosine u, right? Because of this common denominator down here. So sine u times sine u would give me sine squared over cosine u, plus cosine u times cosine u would be cosine squared u over cosine u. What's sine squared plus cosine squared? 1, so this is going to be 1 over cosine u. And 1 over cosine u is equal to what? Secant u. Does that make sense? All right, let's go to the back. Let's look at number 7. So number 7, it's 1 plus sine squared theta is equal to 1 plus cosecant squared theta over 1 plus cotangent squared theta. So let's mess with the right side. And I'm going to rewrite that cosecant as 1 over sine squared theta divided by 1 plus that cotangent. I'm going to change it to cosine squared theta over sine squared theta. Okay. Now I have fractions that I want to add to 1. So that 1 I have to change with that common denominator. So here my common denominator for both is sine squared. So I'm going to multiply by sine squared theta over sine squared theta. So I'm changing both of those values of 1 to sine squared theta over sine squared theta. Okay. So I add my numerators now. So sine squared plus 1 is just going to be sine squared theta plus 1 over sine squared theta. Right? I can combine my fractions now since I have a common denominator. Divided by the bottom, I have sine squared theta plus cosine squared theta over sine squared theta. Now what can I do here? Where? So sine squared plus cosine is equal to 1. So this is sine squared theta plus 1 over sine squared divided by 1 over sine squared theta. Okay. What about now? What do you do when you divide fractions?
Oh, you did reciprocal.
You multiply by the reciprocal, right? So sine squared theta plus 1 over sine squared theta times sine squared theta over 1. So what happens here?
You can cancel out sine.
So sine squared divides out, sine squared theta over sine squared theta And so I'm left with sine squared theta plus 1, which is what it's equal to. Make sense? See, there's different ways that you could do this. There's no right or wrong way. A lot of people today have been starting and then erasing their answer when they were on the right track. Okay? So you just have to slowly think through this. It's a lot of thinking. Okay, try number 10. It's just like the one on the back where we had to multiply this fraction by the opposite denominator, right? Tangent, the opposite denominator was secant, so it was secant over secant. This one was secant, so we multiplied by tangent over tangent. All right, so here I have sine y over 1 minus cosine y, and I'm going to multiply this by sine y over sine y. Okay, and then we're going to add that other fraction multiplied, so 1 minus cosine y over sine y, multiplied by the opposite denominator over itself. So this one is 1 minus cosine y, so I'm going to multiply this by 1 minus cosine y over 1 minus cosine y. Okay? And so sine y times sine y would just be what? Sine squared y over, now 1 minus cosine y times sine y, I'm just going to leave it like that for right now. I'm only going to multiply until I necessarily have to. And then plus, here I have 1 minus cosine y times 1 minus cosine y. So I'm going to come over here to the side and actually multiply that out. So 1 minus cosine y times 1 minus cosine y. So you can either use any of these methods, the box method, or FOIL, right? Here, FOIL would be the first two, which is 1 times 1, and then your outer two, so 1 times negative cosine, so that's negative cosine y. Your inner two, so negative cosine y times 1, which is negative cosine y. And then your last two, negative cosine y times negative cosine y, would be
cosine squared y.
Cosine squared y. And then I can combine my like terms. So this negative cosine y and negative cosine y add up to be what? Negative 2 cosine y. Okay. So now this numerator is going to be 1 minus 2 cosine y plus cosine squared y over 1 minus cosine y times sine y. Right? Okay, now these numerators, what can I add together to simplify?
Sine squared y plus the sine squared y, get 1.
So this is going to be 1 plus 1 minus 2 cosine y over 1 minus cosine y times sine y. Right? Everybody agree? Okay, so let's come up here. So then 1 plus 1 is 2. Hopefully y'all can do that. So it's 2 minus 2 cosine y over 1 minus cosine y times sine y. What can I do here? Starts with the S. Starts with the letter S.
Factor.
What am I going to factor?
2, the 2 on top.
You factor out the 2. So 2 divided by 2 would be 1. And then 2 cosine y divided by 2 would be cosine y. So it'll be 1 minus cosine y sine y. And then what can I do here?
Cancel.
So the 1 minus cosine and 1 minus cosine cancel out. I forgot this y. And so now I'm left with 2 times 1 over sine y. And what's 1 over sine y? So this is 2 cosecant y, which is what we wanted. Any questions? Make sense? Okay.